On est en 2001. Ça te rappelle rien?
Hey there,
Non?
and I know what you're thinking. I came here to learn about Newton's 3 laws of motion. Where are my epic experiments? Where are my cool animations? I didn't come here to look at some ugly Asian kid talk. Well, now at least you know how I feel when I wake up in the morning and brush my teeth. But anyway, here's the first law. An object at rest will tend to stay at rest, and an object in motion will tend to stay in motion until it is acted upon by an unbalanced force. Seems simple, right? Well, this is something we see every day, and it is fundamental to understanding physics. So if something starts moving, it will move in that direction at the same velocity indefinitely until something stops it. An example of this stopping force is inertia. But first, an experiment. Cue epic slow-mo music. We're gonna need an index card, a penny, a glass, and parental supervision.
Hey Justin, I'm pretty sure we can do this one without parental supervision.
Wait, really?
Yeah, it's safe.
Okay. No parental supervision needed in this experiment, but be careful with that glass. Alright, coming back, put the glass here, the index card on top, and a penny on the index card. Now flip the card, cue epic slow-mo music, and see what happens. As you can see, you applied force to the motionless card, but not to the coin. The card moved, but the coin stayed and fell into the glass. The coin was at rest and stayed at rest. Now why didn't the card, which was in motion, stay in motion? Let's do another experiment so I can explain to you another concept. Okay, boom, 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 boom. Okay, stop. Instead of flicking the card, let's pull it. Keep it level.
Okay, so the penny just travels with the index card. This is a result of inertia. Inertia is the tendency of an object to resist changes in motion. The first time we did it, the inertia was lower because there was less friction. Yeah, friction. The force that results when two surfaces rub together. Got that? Now that we have the first law down, let's move on to the second law.
So, Newton's second law. It states that when an object is acted on by one or more outside forces, the total force is equal to the mass of the object times the resulting acceleration. This is talking about force. Force is a pull or push exerted on an object in an attempt to change the object's velocity. This law can be represented as a formula. F equals ma. Okay, so what this law basically means that if there's more mass and more acceleration, there's going to be more force. Force is measured in a unit called newtons, of course named after Sir Isaac Newton, who discovered these laws. Now I'm going to show you a few math problems to demonstrate how this law works.
So, let's say we have a guy who has a box that weighs 300 kilograms. And once he starts pushing it, it begins to accelerate at 0.12 meters per second squared. Well, we know the formula for the Newton's second law is F equals ma. Force equals mass times acceleration. So, we plug everything in. Force equals 300 kilograms, which is the mass, times 0.12 meters per second squared. And once we multiply that, we'll get a final answer of 36 newtons. Remember, force is measured in newtons. This is basically how Newton's second law works. And, using math, we can determine how much force is being applied.
It gets more complex, of course. There's friction and inertia and all sorts of other factors that play into this equation. So you always have to make sure that you account for these whenever you're solving this type of equation.
For every action, there is an equal and opposite reaction. This is Newton's third law. This one in particular is my favorite law because it has to do with rockets. When rockets gain liftoff, they push a huge amount of thrust onto the ground. This thrust is considered a force, and the force pushing back is the ground, allowing the rocket to make liftoff. This is why when we walk, we don't fall to the ground, inevitably to fall into the burning Earth's core. The ground pushes up with the equal and opposite force, so that we are able to walk and maintain our stability. Think of the Newton's cradle. This is an interesting toy. The first ball will exert force through the middle balls, and the opposite force will come out at the end ball. So there you have it. Newton's 3 laws, fundamental to learning physics. And I hope you learned something. Until next time, my name is Justin Dank.
Keep going, just stay here. Okay.